The Development of the Brain and Its Effects on Learning in Classrooms by Michael Sanford, Emily Marks, Marguerite Sutton, and Ashley Leatherbury. As future teachers, it is imperative that we understand how the development of the brain affects cognitive development because it's going to affect what happens in our classrooms. Let's start by educating ourselves on the overall brain, and then we'll learn about development during certain stages. If you click on this image, it will go over some key points as to what we need to know about the overall brain. The question we raise is, do early or later experiences, positive or negative, more profoundly affect a child's development? Still hotly debated, some developmentalists say a nurturing childhood is optimal. Some say children are still malleable during adolescent development. Splinter development is when development is uneven across domains. For example, a student may have excellent math skills but poor language skills. Now, what does this mean for our classrooms? Children who are gifted in academics but are emotionally immature may have difficulty making friends. Emotionally mature students may pay more attention to friends than classwork, and students may experience anxiety regarding a certain area of study while excelling in others. How do we support these students? Have students work in cooperative learning groups, intentionally pair students with different intellectual gifts, and divide emotionally immature students into other groups so they can learn and mimic their peers. Until recently, scientists thought genes determine brain development, but they were wrong. Actually, the brain has loads of plasticity or the ability to change, and development depends on experience. Early childhood begins at the end of infancy and extends to about 5 years. This period is where children become more self-sufficient and develop school readiness skills. Below is the link to a video that reveals the secret life of the brain. And next, we have a video of just how important the beginning of a child's life is to their development. Nature refers to what is biologically inherited. While our genetic makeup includes various components, it is that same makeup that produces commonalities in growth and development. Nurture refers to environmental experiences. Experiences extend from one's biological environment, nutrition, medical care, drugs, and physical accidents, to their social environment, family, peers, schools, community, media, and culture. The importance of early development. In reality, we are both the creatures and creators of our worlds. We are the products of our genes and environments. Nevertheless, the stream of causation that shapes the future runs through our present choices. Mind matters. Our hopes, goals, and expectations influence our future. Myers. Continuity is a cumulative change. A child's first word, though seemingly an abrupt, discontinuous event, is actually the result of weeks and months of growth and practice. Puberty, another seemingly abrupt, discontinuous occurrence, is actually a gradual process occurring over several years. Discontinuity represents the distinct stages. A child moves from not being able to think abstractly about the world to being able to. This is a discontinuous change in development, not a quantitative continuous change. Piaget's theory applies to this as he believed that children use schemas, assimilations and accommodations, organizations, and equilibration to construct their knowledge of the world. Piaget's 4 stages of cognitive development are sensory motor stage, pre-operational stage, concrete operational stage, and formal operational stage. Now we'll move on to talk about the development of the adolescent brain. Nerve endings continue to grow into adolescence, and some of the brains increase in size due to a process called myelination, or the process of encasing many cells. The part of this process that helps children focus their attention is not complete until about 10 years old. Knowing that attention does not fully develop until age 10, what does that teach us about classroom management? What are the implications for students who may be diagnosed with ADHD or ADD? Should we be more patient with students instead of diagnosing? The controversy rages on. Another important aspect of the brain's development at the cellular level is the dramatic increase in connections between neurons. Synapses are tiny gaps between neurons where connections between neurons are made. Shown here are the locations of the brain's four lobes: the frontal, occipital, temporal, and parietal. Total brain volume stabilizes by the end of the middle and late childhood, but significant changes in various structures and regions of the brain continue to occur. In particular, the brain pathways and circuitry involving the prefrontal cortex continue to increase in middle and late childhood. The development of the prefrontal cortex is monumentally important. It houses decision making, self control, and reasoning. Here is an image of the prefrontal cortex. The highest level of the frontal lobes involved in reasoning, decision making, and self control takes place in the prefrontal cortex, which doesn't reach maturation until between 18 and 25 years of age, or sometimes older. Knowing that this area of the brain is still developing in adolescence, what does that mean for our classroom? Impulsive decisions, reasoning is still forming, outbursts, self control is still developing, and extreme personal changes, personality is still changing. How do we support these developments in our classrooms? By giving students structured choices, not whatever you want, but choice 1, 2, or 3. Explaining the reasons for discipline, not merely disciplining bad behavior, but explaining why the behavior is not acceptable in society, and offering supports and resources for children as they develop their personalities and beings. When it comes to brain development in middle and late childhood, links between the changing brain and children's cognitive development involve activation of some brain areas so that they increase in activity while others decrease. One shift in activation that occurs as children develop in middle and late childhood is from different use in larger areas to more focal, smaller areas. This shift is characterized by the synaptic pruning, in which areas of the brain not being used lose synaptic connections and those being used show an increase in connections. Like every other part of the body, the brain changes during adolescence. Connections between neurons become pruned during this time of change, and there are fewer, more selective neurons being used. This pruning indicates what activities children choose to engage in and not engage in. Scientists have recently discovered that adolescents' brains undergo significant structural changes. The corpus callosum, where fibers connect the brain's left and right hemispheres, thickens in adolescence, and this improves adolescents' ability to process information. If pruning occurs based on what the student's brains decide is essential and what is not, how can we help strengthen the synaptic connections that are essential? We can first engage students in school. Second, we can plan activities that engage multiple senses. And third, we can plan lessons that involve multiple intelligences, such as interpersonal, linguistics, logic, spatial, musical, naturalist, and body and kinesthetic. The amygdala, however, which is the seat of emotions such as anger, matures earlier than the prefrontal cortex. The cerebral cortex, the highest level of the brain, is divided into two halves or hemispheres. Lateralization is the specialization of functions in each hemisphere of the brain. In individuals with an intact brain, there is a specialization of function in some areas. In most individuals, speech and grammar are localized to the left hemisphere. However, not all language processing is carried out in the brain's left hemisphere. Understanding such aspects of language as appropriate use of language in different contexts, evaluation of the emotional expressiveness of language, and much of humor involves the right hemisphere. Also, when children lose much of their left hemisphere because of an accident, surgery for epilepsy, or other reasons, the right hemisphere in many cases can reconfigure itself for increased language processing. What children do can change the development of their brain. By engaging students in optimal learning environments, you can stimulate the development of their brain. The remarkable case of Michael Rabin illustrates the brain's plasticity. When Michael was 4.5, he began to experience uncontrollable seizures, as many as 400 a day. Doctors said the only solution was to remove the left hemisphere of his brain where the seizures were occurring. Michael had his first major surgery at age 7 and another at age 10. Although recovery was slow, his right hemisphere began to reorganize and eventually took over functions such as speech that normally occur in the left hemisphere. We don't have to look any further than the hype about left brain individuals being more logical and right brain individuals being more creative to see that links between neuroscience and brain education are incorrectly made. It is clear that not all educational curriculums in other areas of education are focused around how our students' brains develop. What can we do in our classes to work with our students' brains and the way they develop? We can work with our students' development by addressing splinter development with intentional pairings and seatings. We can introduce new ideas while students are still creating synaptic connections frequently. We can enforce ideas during synaptic pruning and make age-appropriate lesson plans with multiple intelligence taken into account. Given all the hype and hyperbole about brain education in the media, what can we conclude from the current state of knowledge in applying the rapidly increasing research on the brain's development to education? Both early and later experiences, including educational experiences, are very important in the brain's development. Significant changes occur at the cellular and structural level in the brain through adolescence. Synaptic connections between neurons can change dramatically as a consequence of the learning experiences of children and adolescents. Connections between neurons that are used when children focus their attention, remember, and think as they are reading, writing, and doing math are strengthened. Those that aren't used are replaced by other pathways or disappear. These conclusions suggest that focused education throughout the childhood and adolescent years can benefit children's and adolescents' learning and cognitive development, and that what we do in our classrooms and the way we do it has a large influence on development. Thank you. For more resources and further education, check out this TED Talk designed for educators to learn about brain development.